uh, the sliding area complete, the lead screw sliding area, the tailstock carriage, the carriage, the tailstock area, and the 3-jaw chuck. Over here, the distance is around 1.5 meters from the two centers. Either we take it identically from the 3-jaw chuck up to the tailstock, or if you are fixing a 4-jaw chuck or a facing plate. There is safety mechanisms where we have an emergency, the hood cover, a braking element to stop everything. The speeds for the spindle will be used with these two gears, where we'll be having it to match up different speed ratios in order to attain the RPM. The feed chart is being used with this chart, what we will be going through today. These charts are actually for the threadings. In threading, you have a metric chart, an inch, module, and diametrical pitch charts. So identically in different regions, they use different types of threads. Mostly Americans and Chinese, they use the inch threads. Asian countries, they use the threads. So in order for having these charts to follow up through, we will have to follow these three symbols, what you will see on each chart. These are actually the 3 gear mechanism what are fixed on side of the
the symbol is the gear. Three. Okay.
Currently you have this 3 gear setup, which is 32, 85 and 100, which will give you all the feeding speeds for your longitudinal as well as the cross feed. So you can do auto feeding for both X and Y axis, X and Z axis to run it through completely. Some cases what happens where they have the reverse mechanism, where they do inch threads, they have it in opposite way. So the carriage mechanism system completely works away from the chuck, and this is towards the chuck.
Okay, but the threading, I think, remember what we discussed yesterday, so we won't really...
So you will not be doing the threading. So in this case, these gears, you will not, you have many gears what are being given in the system. So unless and until this is not fixed, you will not get it. So in your cases, gears will not work. So for you, you can do all types of turning, step turning, taper turning, drilling, countering, boring, knurling, with auto feeding. With manual as well as auto feeding in both mechanism, except the threading. All things are possible. So we will gear mechanism towards the chuck or away from it. The pitch thread charts used with the help of combination of the external gears. The feeding gear chart used with the help of same combination of the feeding chart, the gears. These 3 knobs, 1, 2, 3, 4, 1, 2, 3, 4 are used for having the combinations of either the threading pitch or the feeding pitch. So let's say if you want to...
Shall we ignore the threading? And
so yeah, I don't think
it's the same actually. Okay. Just to give you an information in future, if in case you have, if in case you want to know how I want to set the pitch, then you will have to use only this 4.
Okay.
The ones what you are using for auto feeding are the same for threading. You're not going to use it, it's okay. It's only like an information. In future, you might require it or something.
So this bit we really won't need then, will we?
No, we need
this. You will need this for doing auto manufacturing, for auto feeding the tool.
What is auto feeding
again?
So if you come in the front, I'll give you an explanation and idea. So let's say if you want to have any speed for doing X and Z feeding, you have to follow the L-shape angulation. For example, let's say if I want to go with 0.297, which is the longitudinal travel, and the 0.08, which is the cross feeding, I have to set my gears in P, B, D and V. So that means this will be in P, B, D and V. So you have to match it like an L formation. Any chart which you want to pick, for example 0.122 and 0.033, we will have to set it in P, B, C and T.
So but is there anything like an ideal one, like
no,
where like
with different materials every time it will always change. Aluminium, mild steel will always speed compared to the spindle speed, which will be slower. For this one I tried with 2 different speed rates, and then I found it earlier I went with a higher speed rate with a slower feed rate, and the finish was not good, so I had to reduce down my speed.
Can we not change the speed only here, like make it low and like in the auto feed?
Speed is only to be changed here.
Yeah,
the
but
spindle
this combination
this is the feeding for your carriage, and this is the speed for your chuck.
Okay.
Or so feeding for the carriage, the automatic feed.
Automatic feed. If you're doing manually, it's only turning with your hand. And if you're doing automatic, we will engage levers, make sure the gears are set. It's same like driving your car. If you push your acceleration, you'll get to 120, 140. But you put it in the correct gear, you will go higher. So that's the same mechanism. If you want to have the correct speed for the chuck, we'll have to use this. If you want to have the correct speed for the carriage to do the correct feeding, because even if, let's say, the speed is correct, and if I'm going very slow, I'll get burrs on top of my workpiece. And if the feeding is too fast, it will spoil the tip, it will break the inserts, and it could cause any damages. So you will have to have the combination of the feed as well as the speed in order to match the correct surface finish required. For each different material, it will always be varying. You will have to trial and practice, or there is formulations what is used. For example, like let's say you want to obtain a correct certain amount of speed. So what they use is they use SFM multiplied by 3.2 divided by the diameter of the tool. SFM is the surface feed passing per minute multiplied by pi, which is 3.8, and multiplied by 3.8, it's a denomination which is used in calculation, divided to the diameter of the tool what you're using. If your tool is 16 mm, 12 mm,
Like engineering all back again.
yeah,
But to be honest with
which is the feed rate for this carriage, okay, and this is the longitudinal which moves your x-axis, okay, and that's the cross feed which goes front to back for doing facing operation and doing turning operations.
basically we always do
So
manually.
if you can also do automatic and also do manually. So let's say if you want to have a certain feed rate for any of this which you feel could be correct for your
How
set
do
of
we know the
workpiece,
feed rate for each?
you'll have to
material?
trial, either you use the formulations or you try them.
Oh, the formulas.
Either you use the formulations
It's got to be a
used in your case, I guess. So, but that's the lever what you can use, and this will be for
What
spindle.
if it's accidentally we put it down? What will happen?
No, you are not using any gates. You are not setting this chart,
Okay.
so it will not do anything. Your Z-axis, the tailstock, locking for the carriage for longitudinal and cross feed, thread gear engaging lever, and for spindle clockwise and anti-clockwise revolutions. Rest all features are the same. We have the brake for stopping if anything goes in emergencies, the coolant, lamp, and the safety guard. So I'll just go ahead and switch on the system and so I'll release it. I'll switch it on, release it, jog. So in this case, you will see if in case the gears are not meshed together, the spindle will not match. So I can lock it.
This is a new one. Our old one never had that. What does that do?
That's jogging. So you can just jog it and see if everything is running
Like
or
it's
meshing
meshed.
together.
Oh, okay.
Yeah.
But sometimes it wouldn't spin.
So sometimes this will not spin
We
because
used
the
to do it
gears
manually,
are,
so you have
Yeah.
to move the gear.
That's
and
what I was
move
saying,
that,
yeah, and then do it by hand. Yeah.
so some people do it manually, or you can use the jog and just see if it's working
Like
or
a
not.
pulse in the mixing.
Yeah.
Yeah. Okay. So okay, I'll go ahead and fix the workpiece.
Is it smaller? No.
Yeah, this is small.
Your future purpose, if in case you're planning for threads and other different
This is a
operations.
toolbox, you mean?
That's a toolbox. So you'll have two toolbox for the big ones and two smaller toolbox. They both are having the same contents.
Each has two toolboxes.
Yeah.
Oh, okay.
So you have four toolboxes, four additional revolving centers given along with it, four-way tool post for each one of them. This is the quick action tool post what you have purchased. So that's an additional component which can be used directly for fixing any workpieces. Basic spanners, tools and accessories. That's the basic lathe set what we have provided. So you have like 4 internal tools and 4 external tools.
When you say internal, for like boring out like an internal
Yeah,
tunnel or
once
something.
you have drilled anything,
Oh,
you
I
can
see.
use these ones because they do have longer shanks which can be held in
I
the
see.
same four-way tool post to use the inner one. People do use this
No,
for
it
external
is not
also.
to the other.
Set one of the four-way tool, the quick change tool post. In this quick change tool post box, you will get 4 smaller ones. 1, 2, 3, 4 smaller ones, and this one is actually the big mechanism what is being fixed here. Okay, so you will see the tool post, which is what we have supplied. So you have 4 of these things. They can go with different ones. There will be one parting tip tool supplied along with the tool post, the quick change tool post. But these are the tools what are being supplied from the basic set. So we have the roughing tool, the finishing tool, the threading tool, parting or grooving tool what we call. This is only to be parting for a smaller diameter objects, and this is for using for multiple big diameter workpieces. You can extend this.
Which one?
This is the same tool.
The workpiece will always have to make sure that everything is aligned centrally. So the easiest process what we do find is always to make sure that the tailstock point is always towards the center of your workpiece. That gives you an easy understanding whether your jaws are not gone wrong or they are not in eccentric positions. Once,
Sorry, say that bit again. What are you talking
in
about?
order for you to make sure when you're doing correct manufacturing, the easiest process is to make sure that the tool center is always
okay.
matching exactly. In some cases, if you're using a forge or an facing
might be
plate,
off.
it might be off. So you'll have to bring that into a center.
But you haven't drilled any hole for this.
No, so we'll be going one by one. What we'll do with that thing. So the first thing is that is parallel to your chuck. In order to have that incremental advantage, what we do is we just bring the tailstock and see, or you just bring it to the tailstock edge
That's a clever way of doing it.
and then just check it.
So again, that's just a visual thing, isn't it?
Yeah, but this will give you accurately exact because you have always made sure that you have touched the center of the workpiece first, and whatever machining happens on the lathe, you'll
Yeah.
always happen on the center. If you're on the top or on the bottom, you'll spoil everything.
No, I get that, but what I'm saying is, how do I know
Yeah.
that
You-
this has lined up with that?
You just
is
have
that
to
again
visually-
just a visual?
Yeah, you have to visually
It'll
see
be
them.
touching it, tips will
Or you
touch.
can touch them. Most
What
of
are the tips? You can't make the tips touch.
some of them will touch, some of them won't.
It's easier to guess that than it is to guess the face.
But the easiest will be this one. Once you have seen it from here, if you line with this tool from the eye having at this level,
Yeah.
from the front over here,
Oh, from this angle you can. You
From
can
here.
actually see it quite well.
from here, exactly straight from this point.
Yeah.
Just see a view from this point in the front.
Yeah.
You will see that this tip and the tailstock is
We
both
never
at the same.
checked this before.
Never checked that.
I didn't
We'll
know
just
that,
guess the
but
middle.
I'll just guess it. I'll go and touch the workpiece.
Start
and
facing
then-
off until.
Yeah.
until
Well, no.
you
Usually,
have
what I
it.
would do, I would just put a little mark on there with the drill bit. So I'd move the tailstock in, and it makes a little mark, and then I would bring the cutting tool, and then I would line it up with that mark.
Many. And what I'll do is, if you see right now, if I start playing
Yeah,
with this,
it's
it starts going down or up.
Yeah. So you have to loosen that top now.
Right now, for one machine, these are the exact 4 lengths what I have set for one. If you just duplicate them for other ones, for these they will be the same because your quick change tool post has the same height. So in this case, it has to be exactly on the point or a little bit below from the point. It should not be above.
Before